this video, we will discuss about triangular law of forces and polygon law of forces and momentum and simple problems. So, triangular law of forces: if two forces acting simultaneously on a particle be represented in magnitude and direction by the two sides of the triangle like P and Q, taken in order, the resultant may be represented in magnitude and direction by the third side of the triangle taken in the opposite direction. See, the force P, towards right side and of course Q towards upward, and we have to take in order OA. It represents vector P. OA. The vector OA represents force P, and the vector AB represents Q, and this is in the anticlockwise direction, and the resultant, which is equal to resultant represented in magnitude and direction by the third side of the triangle. This is first side of the triangle, this is second side, and this is third side of the triangle, and taken in the opposite order. This is in the clockwise direction, right? Similarly, if three forces, we can use this triangular law. If more than three forces, so we can use this polygon law. Similar same procedure, if the number of forces acting simultaneously on a particle be represented in magnitude and direction by the sides of polygon taken in order, then the resultant of all these forces may be represented in magnitude and direction by the closing side of the polygon taken in the opposite order. Force F1, F2, F3, F4 and F5 are acting from a single point O. Then we have to draw a force polygon. Then for F1, it represents the horizontal direction, and we have to draw a line which is parallel to F2 and F3, and from this F4, this is F4, and we have to draw a line which is parallel to F5 with magnitude. Then the closing side, which is called as the resultant. See, F1, F2, F3, F4 up to F5, which is in the clockwise order, and the resultant in the anticlockwise direction. Right. Now, momentum, it is the turning effect produced by a force on the body on which it acts. The momentum of force is equal to the product of force and the perpendicular distance of the point about which the momentum is required and the line of action of the forces. So, momentum, which is equal to force into perpendicular distance, right? Now, see the picture, and now we want to take moment about this point, right? So, we have to apply the forces here, and the momentum, which is equal to force into perpendicular distance, and I want to take moment with respect to this point, then force what I want to apply and d, the distance between the perpendicular distance between the force and the momentum at which the point we will take momentum, right? So, the force and the perpendicular distance of the point about which the momentum is required to take. Okay, and see, if sometime the forces we will apply in the inclined angle, then we have to draw the line and take the perpendicular distance from the moment where we taken. This is the Varignon's theorem or principle of momentum. If a number of coplanar forces are acting simultaneously on a particle, more than 2 or 3, then the algebraic sum of the moments of all the forces about any point is equal to the momentum of the resultant force about the same point, right? See here, this is x axis and this is y axis, and this is force 1 and force 2. Two forces are acting here, right? Now from this point we have to take moment. So, draw a line which is perpendicular to this F1, and draw a line which is perpendicular to F2, and draw a line which is perpendicular to resultant, right? So, force into distance r into this perpendicular distance r d, which is equal to F1 into d1 plus F2 into d2, right? Sum of the momentum of forces which is equal to the resultant momentum, right? It's a simple problem. Let me explain. A force of 15 Newton is applied perpendicular to the edge of a door 0.8 meter wide as shown in the figure. Find the momentum of the force about the hinge. So we want to take moment about this hinge point O. How much force we applied? 15 Newton, and what is the perpendicular distance between this force and the momentum where we want to take, which is 0.8 meter. So momentum which is equal to force into the perpendicular distance, so which is equal to 15 into 0.8 meter, right? So 15 into 0.8 meter, 15 into 0.8 meter, which is equal to 12. So m which is equal to 12 Newton, right? Newton meter, right? Sorry, Newton meter, because force into perpendicular distance, force the unit which is equal to n, and the perpendicular distance in terms of meter, then the unit which is equal to Newton meter, right? Similarly, suppose instead of applying force perpendicular to this door, now we are going to apply some inclined 15 Newton with inclination 60 degree. Then already we discussed the force, the inclined force, whatever may be the inclined force, the force we have to resolve into two components. One is horizontal component, another one is vertical component. So this is 15 Newton, right? So vertical component in downward and horizontal component in this, right? So this is 15 sin 60 degree, and this is 15 cos 60 degree. So we have to draw a line, and this is theta, and theta side which is equal to opposite side, downward, right? Opposite side, that's why this line which is similar to or parallel to the vertical force, that's why here the vertical force. Right now, force into perpendicular distance, force which is equal to 15 sin theta, I mean momentum which is equal to 15 sin 60 degree into perpendicular distance 0.8 meter, right? So what is the value? What is the value? 15 into sin 60 into 0.8, which is equal to 10.39 Newton meter. So let me check. 10.39, approximately 10.4 Newton meter. Clear? Right? See, this is graphical method and this is analytical method. Already I told you the 15 Newton is divided into two components. One is horizontal component, another one is vertical component, right? So the force into perpendicular distance, force which is equal to 15 kilonewton, I mean 15 sin 60 degree into this distance. So if we want to take 15 cos 60 degree, then we can't measure the perpendicular distance which is equal to 0 with respect to this point, right? So this is graphical, this is analytical method. And how to draw a graphical method? See, draw a line parallel to this 15 Newton, right? And from this point, from this moment point, we have to draw a line which is perpendicular to CB, right? So the OC which is perpendicular to OC, which is perpendicular to CB or BC, right? So now measure this. Now measure this. Now measure this value, right, into force. Then that is momentum. Clear?